The ready portion for lesson 1.9 is really just getting you to reinforce the idea of arithmetic and geometric sequences. So when we're talking about similarities between the two, we can say that arithmetic and geometric are constantly changing. As in, they both change at a constant rate. However, arithmetic sequences change by addition or subtraction, whereas geometric sequences change by multiplication and division. There are other ways to say it, and there are other things that we can focus on, but right now, those are the big pieces that I want you to think about. Please forgive my sloppy handwriting. So there are a number of ways that you can go through this problem. So one way that you can do this is to just guess and check. It's because I need for number 4 to be able to take and jump to 26. So I could say plus 10 is 12, plus 10 is 22, plus 10 is not 26. I know that doesn't work. So I know that has to be smaller than 10. What about 9? 9 plus 2 is 11, plus 9 is 20, does not give me 26. 2 plus 8 is 10, plus 8 is 18, plus 8 more is 26. So that would work. However, that starts to get a little bit cumbersome. And as you will have heard in the lesson, there are other ways that we can find that number. So something that we can do is we can take our last term, 26, minus our first term, 2, and divide it by our last input minus 1, so 4 minus 1. So that would be 24 over 3. So we know that our common difference is 8. And if I add 8, I get 10. Add 8, I get 18. Add 8, I get 26. Let's do number 5. So the last term that we know is 6. The first term is 24. And we're going to go with our 3 minus 1 because we're going with the third term in the table. So that would be negative 18 over 2. So that would get us a negative 9. So I should be able to take 9 and subtract it from 24 and get 15. 15 minus 9 is 6. 6 minus 9 is negative 3. For number 6, again, I'll take the last term that we know, which is 4, minus our first term, and then our input minus 1 to be able to find our average. We have negative 12 over 3. So in this case, we are subtracting 4 each time. For the go portion, number 8, if we look at the pattern that is forming here, 60 to 30, 30 to 0, 0 to negative 30, they are going in the same chunks of values each time. So we know that we are subtracting 30 each time. We know that our first term is 60. So for our recursive equation, f of 1 equals 60. F of n equals the previous term minus 30. For the explicit equation, we have f of n equals our first term plus our first common difference, which is minus 30, times n minus 1. For number 10, number of black tiles above. So you can say that there's one tile, there are 2 tiles, there are 4 tiles. So each time, by the way, number 8 was an arithmetic sequence, because for number 10, as this is going, we are continuing to double the amount of black tiles, which means that this is going to be a geometric sequence. For the recursive equation, define your first term. There's 1 tile. And to find every next term, we're going to take the one right before it and multiply it by 2. For the explicit equation, take your first term, multiply it by your common ratio to the power of n minus 1, and you are finished. Hopefully this helps. Reach out with any questions you might have.